Hello, this is question 10 from the step 2 paper from 2022. Looks like we've got some projectiles here. This is the second mechanics question in the paper, and they go straight in, no intro. Part 1, show that if a particle is projected at an angle alpha above the horizontal with speed u, it will reach height h at a horizontal distance s from the point of projection. Okay, where h is all of that. Right, you might have seen that equation before. This is just doing the y as a function of x equation of a projectile. So we're getting to this through looking at the parametric equations. So we can put the y and x in terms of t and then eliminate t. So in this case, y in inverted commas, so that's our height, is going to be equal to h. So we're doing, this is one of those occasions where SUVAC is useful and can be a bit quicker. So we're doing an s equals ut plus half at squared. So our ut is going to be ut sine alpha, and our half at squared is going to be, so minus, because we're accelerating downwards, so g over 2 times t squared. So that's the y bit. Our x is going to be s, which is just going to be ut cos alpha. So I just have to eliminate t in these, and then everything will be fine. You know, that one is given that t is s over u cos alpha. So put it into this. So h is going to be ut sine alpha times s divided by u cos alpha. So the u's cancel, and we're going to get s tan alpha. And then we got minus, so g over 2. Let's do a big line because it's going to be a biggish fraction. Just got to put in the t squared here, so s squared u squared cos squared alpha. Right, so that wasn't too bad to get us going. I doubt they gave us many marks for that. The remainder of this question uses axes with the x and y axes horizontal and the z axis vertically upwards. Okay, the ground is a sloping plane with equation z equals y tan theta. Right, I don't think I'm going to be drawing that very well. And a road runs along the x-axis. Right, yeah, and the x-axis will be flat. A cannon, which may have an angle of inclination and be pointed, any angle of inclination, I say, and be pointed in any direction, fires projectiles from ground level with speed u. Initially, the cannon is placed at the origin. Right, so the picture is going to be quite tricky to draw on this. So, but what we're really looking at, and I'm going to, because trying to draw a plane in 3-dimensional axes is just horrendous, so I'm not going to try and do it. So we've got z going upwards. I'll draw y going over here because these are the ones of interest. So rather than drawing the x-axis sort of going off this way and then trying to draw something artistic, just imagine the x-axis is coming straight out of the screen at you, because it's z and y that are of interest for the slope. So the slope is going to be something like this. Of course, we can have negatives. So let's extend the axes. Now we've got that z is y tan alpha. So z equals y tan alpha, not alpha, theta. Alpha was in the first part of the question, wasn't it? So tan theta is z over y. So that means that is going to be theta, opposite over adjacent. So that's giving us the angle of the slope. And the x-axis, so if you're moving just in the x direction, you're moving across the slope, not up or down, you're just moving side to side. So you're not changing in height if you're moving along the x-axis. So the x-axis is just flat, that's flat ground. And we've got the cannon stuck here. So anywhere, if the cannon's at the origin, anywhere along the x-axis is level with the cannon. Right, so anyway, that's the picture that I'm going to be working off of. Part 2, let a point P on the plane have coordinates x, y, y tan alpha, tan theta, so it's just x, y, z. Show that the condition for it to be possible for a projectile from the cannon to land at P is all of this. Right, well, I'm going to want a new sheet for that. So, yeah, so I want to be saying then, so h is going to have to be greater than, well, when they hit, h is going to be our z coordinate. That's what we've got. So we need solutions for when, so z is equal to h and z is y tan theta. So we've got that bit. and then we've got S, which I'm imagining they have eliminated. Yeah, they've got rid of S in here as well. That would make sense. So S is our horizontal distance. So that is in the XY plane. So our S is going to be the square root of x squared plus y squared, because we're just in the horizontal plane. So I can stick all of that into here, and hopefully that will, well, provided we can solve it, then that will be okay. So I'm thinking this less than or equal to is going to come from the discriminant of something. It would have to be something to do with alpha, because that's not in the answer. So I want to get a quadratic in either cos alpha or tan alpha, or something like that anyway, when I put all this together. So I've got a y tan theta, that's h, is the square root of x squared plus y squared times tan alpha minus gs squared, so that's g times x squared plus y squared, over 2u squared cos squared alpha. Right, so the tan alpha is going to be harder to change. It's going to be the cos squared, so that's a sec squared. So I can use the relationships here. So a sec squared is 1 plus tan squared. So that means I've got square root of x squared plus y squared times tan alpha minus 1 plus tan squared alpha, and then I'm left with what, a g and a x squared plus y squared and a 2u squared. Jeez. But I have got a quadratic in tan squared. So let's see what are my A, B, and C is going to be then. So A is going to be, I've only got one tan squared, and I'll make that tan squared a positive. So it's going to be g x squared plus y squared over 2u squared. So that is my A. And then B, I've only got the one tan alpha, so that's going to be minus the square root of x squared plus y squared. And then for C is the stuff that's left. So I've got a y tan theta, and then I'm going to have a plus g x squared plus y squared over 2u squared. Ugh. Okay, so if we're going to get this to solve, we need the b squared minus 4ac to be greater than or equal to 0. So I'm going to need my b squared, my x squared plus y squared to be greater than or equal to the 4ac. Oh, that's a real mess, isn't it? 4 times g x squared plus y squared over 2u squared, that's my 4a, times y tan theta plus g x squared plus y squared over 2u squared. Good Lord. I mean, I suppose this thing is a mess, but it's still trying to get that thing to match up. Let's close the bracket over here. So, right, it's not entirely, how do I want to go about rearranging all of this? Because that looks really unpleasant. So I've got, well, I suppose I could multiply, do I want to divide through by the x squared plus y squared? So probably not, actually. Well, actually, I might do. Coming to look at it all. And then, but I want to get rid of those g's as well. So yeah, let's try doing that. So let's do a little bit. I'm just doing this to save some space. That will become a 2. Get rid of that. And then I could cancel this to leave a 1 and get rid of that. And then what would I want to do next? Maybe put a u squared over g. Oh yeah, which is appearing over here. So that doesn't look too bad. So I've got u squared over g is greater than or equal to y tan theta plus g x squared plus y squared over 2u squared. No, it doesn't, because I've not dealt with that 2. So that means I'd have to have a 2 there and get rid of that one. Right, so that looks better. Right, so this is sort of getting close. If I get these, multiply by another u squared, divide by another g, then that helps, doesn't it? So yeah, let's go with that. So I'll multiply everything by u squared. That'll make that 4. Gets rid of that, and it puts a u squared in here. So really got anywhere to put it. 2y squared tan theta. Divide through by the g, gets rid of that, puts that over g, which puts a g squared there. And then I've got the x squared plus y squared bit. Right, so I need to somehow get that. It's sort of looking like it, isn't it? I've got the x squared, I've got the u to the 4, I've got the g squared, I've got so that's u squared tan theta over g. Oh, they've completed the square. Yeah, okay, right, I can see where we're going. So u to the 4 over g squared is greater than or equal to, so it's going to be x squared plus, and then complete the square on y, so that's y plus u squared tan theta over g, just as we want, squared, and then take off, that's going to be u to the 4 tan squared theta over g squared. So I'm going to add that to the other side and get a 1 plus tan squared, which is a sec squared. Yeah, wonderful. So u to the 4 over g squared times sec squared theta is then greater than or equal to x squared plus all the stuff in the bracket, y plus u squared tan theta over g all squared. Right, so that was yeah, long-winded, but it wasn't too bad, providing you're all right with your trig identities and you just keep track of everything that's going on. A lot of this as well is when they got that show that, just see what's not in it. You know, there's no S there, there's no alpha there, there's no H there. So these are the things that we're all clearly wanting to get rid of. So you need to find things to replace them with. So that's how we get rid of S, that's how we get rid of H, and then we get a quadratic in order to get rid of alpha. So, but still, that was a fairly hefty bit of algebra to work through. But that's done part 2. So on to part 3. So show that the furthest point directly up the plane that can be reached by a projectile from the cannon is that distance from the cannon. So the furthest point directly up the plane. So if we're going straight up the plane, then we're going along the y-axis, so we're not getting any x value. So we're going so along y-axis, so x equals 0. And then we want the distance up the plane, so that is the Pythagoras for z and y then, isn't it? So we want our distance to be the square root of y squared plus z squared. So that is the square root of, well, z is y tan theta. So we've got y times the square root of 1 plus tan squared theta. So that is y sec theta is what we're after. Right, so that should give us quite a lot to work with then. We've got this, x is 0, so let's stick some stuff in and see where we end up going. So we've got the y plus u squared tan theta over g squared is less than or equal to u to the 4 sec squared theta over g squared. So square root both sides, take off the u squared bit. So I've got that y is going to be less than or equal to the, well, I'll put a negative there because I know that's going to be a negative. The other one could have a plus or a minus on it. Plus or minus u squared sec theta over g. And then I need to multiply by sec theta on this. So I've got then that y, well, not, I don't want y now, I want d is less than equal to, I'm going to want a plus or a minus on here. So I want to go the furthest point directly up the plane. So that's going to be, so plus will be up, minus will be down. So I want that to be, so I've got u squared, I need to multiply all this by sec, so sec squared, and then theta over g, minus u squared tan theta sec theta over g. So d, let's factorise some bits so I can get a better look at what's going on. I've got the u squared over g, and then I've got a sec theta, and then I've got a sec theta minus tan theta. Okay, so that's 1 over cos minus sine over cos. So 1 minus sine over cos, and then yeah, okay, right, yeah, I can see where we're going. Right, I can see where we're going. So yeah, u squared over g, and I've got a 1 minus sine theta over a cos squared theta, which is a 1 minus sine squared theta. So the 1 minus sines are going to cancel and just leave me with a 1 plus sine on the bottom. That's u squared over g, 1 plus sine theta. Okay, so there we go. So we've got our d max then. So d max, therefore d max is equal to u squared over g, 1 plus sine theta. So that's when we're firing up the plane. How far from the cannon is the furthest point directly down the plane that can be reached by a projectile from it? Okay, so in this case, we're now taking the negative there. So we're going to have, let's change for blue. So I've now got that d is going to be less than or equal to minus u squared sec theta over g, and then we'll have a plus inside the bracket. So if I've got that set up, then I'm going to have a sec squared. I'm going to have, how am I going to put this together? So I'm going to have a sine, well, it's going to be a plus, a 1 plus sine theta. So it's going to leave me with the 1 minus sine theta on the bottom. So I'm going to have that d is less than or equal to minus u squared over g, 1 over 1 minus sine theta. So the d max is going to be the magnitude of this thing. So therefore, I'm running out of space a bit here, d max for downhill is going to be equal to u squared over g, 1 over 1 minus sine theta. Right, so yeah, pretty similar. We just got that one change in sign because of this thing here. Plus for going up, minus for going down, we're just doing the same thing, and then we're taking the magnitude. We're actually getting displacements out of this rather than, and then we want the distance, so we're magnitude of it. Right, that's fine and hunky-dory. Right, so part 4. Yeah, I've got another blank sheet here. Find the length of road which can be reached by projectiles from the cannon. So find the length of road which can be reached by projectiles from the cannon. So this is where we're looking at the x-axis, which is where the road is. So on the road, we've got that y equals z equals 0. And, well, theta's not going to manage. We're just firing along flat land here. And the length of road which can be reached by projectiles from the cannon. Yeah, and this is just flat land. On flat land. So we've got a theta is equal to 0 as well. So that's no real problem on this. So we've got, what have we got on all of this? I've got the x squared, and then I've got this thing here is 0 in the brackets. I've got 0 plus 0, and then here I've got u to the 4 over g squared. So we've got x is, so maximum distance, x max is equal to u squared over g, and we could fire it in either direction. So the length of road is equal to 2x max, which is equal to 2u squared over g. So that's okay. Cannon is now moved from a point to a point on the plane vertically above the y-axis. Okay. Distance r from the road. Find the value of r which maximizes the length of road which can be reached by projectiles from the cannon. What is this maximum length? Right, so we've now got, so if that was our slope, we've moved up here some distance r, that angle theta. So that's y, that's z. So we've moved the cannon in the y direction. We've moved it, I mean, we don't really care about the z direction in this because we've removed that from here. So we just need to take care of the change in y. We haven't changed x. That still stayed exactly the same. It's just y that we've moved the cannon in terms of that inequality. So we've moved from y equals 0 to y equals r cos theta. So we need to get back as if y is back at 0 again. So we need to subtract r cos theta from y. Subtract r cos theta from y in that inequality. And then we just need to do it again and then try and find out what x value we're going to get. So, and then double it up. So how are we going to maximize x in all of that? So I've got the x squared plus y minus r cos theta, that's translating us back to the origin, plus u squared tan theta over g squared is less than or equal to u to the 4 sec squared theta over g squared. So we're going to get a maximum, so therefore maximum x when the bracket is 0. Bracket is 0. So we've got the x max equals u squared sec theta over g. So we're going to have double that. So for our maximum length, therefore maximum length of road equals 2x max as we had before, which is equal to 2u squared sec theta over g, and that happens when that bracket is equal to 0. So we've translated it back to the origin on this, so we can put the y is 0 in there, and we're going to have the r cos theta. So when r cos theta is equal to u squared tan theta over g. So that's what we want on all of this. So that means I've got r is equal to u squared over g sine theta. I suppose you could write this either way, really, can I? So I'll say sine theta sec squared theta. I mean, I could put tan theta times sec theta. It's all the same setup, really, isn't it? But still, I'll go with that. That looks all right. And I think that's it, really, isn't it? Is that everything they wanted? Find the value of r which maximizes the length of road which can be reached by projectiles from the cannon. What is this maximum length? Yeah. I mean, you can see how this was the same thing that we had before. We were saying that if we're on this flat land here, we're just considering the x-axis, so we're saying that y is equal to z is equal to 0, and then we stuck that into here with y is 0. In this second case, we just need to translate it back, get the cannon back as if it was at the origin, so by changing that y coordinate, and then do the same thing again, put in y is 0, and then see about maximizing x. So Yeah, I would say that was a fairly tough question. I think that was more difficult than the first mechanics question in this paper, I think, all in all. Okay, the first part was fairly standard, but then parts 2, 3 and 4 were all fairly difficult, whether it was tough algebra or this translation back to the origin wasn't particularly straightforward either. But I do like mechanics questions, so quite a nice one for me.